So I'm just going to do this completely unscripted because I don't feel like writing another script for this. So this is just a quick explanation on the math that I did for my last video on artifact probability shenanigans. And so I linked a sheet like way later than I should have. I should have prepared this on release, but hindsight's 2020. Do it next time I do math stuff. But anyway, let's just go through the stuff that I just ran through overall. So first is the chart that I showed in the video. This is just taking the binomial probabilities and just adding them all up. So, right, and just a quick explanation again, this 3L means it's a 3-line start, which in other terms means that A, the artifacts start with 3 lines, and B, that it only gets 4 possible rolls instead of 5. When it's a 4-line start, it gets 5 total rolls. 4, 8, 12, 16, 20. Versus 3-line, it's just 8, 12, 16, 20. So yeah, this just adds it up. It's a cumulative probability, not individual. That's the baseline for the stuff that's down here. And this part is from, not that, this. So the issue with trying to find like the probability for the starting number of substats is that, well, the substat distribution is uneven, right? You got flat HP with 6, all the flat stats with 6, percentage stats EREM with 4, and crit with each crit with 3. And so the problem here is that, well, when you roll the stat, you can't roll it again, so it has to be taken out of the list. So what I've done is just set up a little thingy that basically solves this problem through casework. So first it sums up the total number of substats, right? This column here represents choosing a main stat. So if the main stat was flat HP, like it is on a flower, yeah, I was about to say feather, changes that to 0, total number of substats becomes 38. Then I selected the select a good thing, which checks off, okay, which substats are good. So in this case, for Xiangling, it would be attack, EREM, crit damage, crit rate. So all 5 of those are clicked. There's a total of 5 good substats, and by extension, 4 bad ones, right? This is eliminated, 1, 2, 3, 4. And so this just adds up all the ones that are good, and then the rest are left to be bad, right? So we got 18, so we got 4 plus 4 plus 4, 12, 15, 18. And then the rest is 20. So by this, we can calculate the probability for the first subset, which is just C15, which is the good sum divided by the total. Simple enough. Probability bad is the inverse of that. Well, not inverse, but I guess 100% reciprocal, we'll call that. Complementary percentage, that's a better word. So then, what needs to happen is, well, the total sample size has to be reduced. And how much do you reduce it by? Well, I decided to, instead of checking it each individually, case by case, I just decided to average it all out. So, right, there's a good sum of 18, 5 good substats decreases by the average of that. So 18 divided by 5 is 3.6. And that's why the total goes down from that to that, and the good sum from that to that. Right, bad sum stays the same because you did not remove a bad subset. However, I can uncheck this box. Ooh, we're using this probability now. Okay, we'll say that this is a bad sum. So there's 20 population of bad sum. For 4 bad substats, average weight is 5. Even though none of them actually have 5, I'm just using that to account for all the cases in general. I'm not actually sure if that has a major flaw or anything, but should be close enough, I guess. Limitations of not actually having taken a statistics course. Oh well. So then, right, bad sum changes, total sum changes, we get subset 2, we decide if it's good or bad, right? Uncheck, check, woohoo. And say it's bad again, right? This changes again, instead of being removing from good substats, it removes from bad substats. And you just go down the list, and then this total here just multiplies all of the ones that are checked in green, right? Because that's the individual probability of each one having a certain role. And so what this basically does is, well, I have all these checked, right? So this is 5 desired feather and flower. You can see 1.84%. That's just the number that I wrote down, copying it from this, right? This is a flat HP thing. We got 5 valuable substats: attack, EREM, crit damage, crit rate. And so there's only one way to arrange that, right? All 4 substats have to be good. So what happens if you don't want all 4 substats to be the same? So we uncheck this one, right? 5.886%. And that's if 3 of them are good. But that doesn't match this. And that's because there's 4 possible ways to have 3 good substats. Right? This, 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 and this. And something interesting to note is that there's a very slight favorability for good substats to be later in the substat line, just because I'm pretty sure all cases, maybe there's fringe cases where this isn't true, but usually the good sum is less than the bad sum, so it's more likely that the bad sum gets chosen first and then the good sum gets chosen later. So cool thing, but usually you won't actually see that in your results, because you'll probably discard an artifact if it doesn't have those good substats in the beginning, because most artifacts are over 3 lines and the 4th line is hidden, and even if the 4th line is most likely going to be a good one, you're probably already discarding that artifact and putting it in the artifact strong box probably. So yeah, little useless fact there, yay. And so a shortcut that you can do is, so there's 1 case to check for here, 4 here, 6, 4, 1, that's Pascal's triangle. And so I don't have to check the 6th one because it's just gonna sum up to 100. So just 1 minus all of these and you get the 2 substats instead of having to check all 6 cases. And yes, I did manually check them just in case to make sure that my machine wasn't doing anything stupid, and it isn't. The probabilities match, so I just took that shortcut because it's convenient. Yeah, ignore this. I was just testing a video that I saw mentioned. Hypergeometric distribution, which is like a simplified version of this, but instead of having things be their special numbers, everything's just 1. And it does the same thing of taking out a substat. So yeah, this is like a manual method instead of using a fancy formula. Woohoo. So anyway, I got a bunch of these tables for basically all of the most common artifacts that you'd be farming for a damage dealer. So, alright, this would represent either an attack % goblet, attack % sands, attack % circlet, whatever. Just this is the main stat. Damage bonus, which can only be on the goblet. Crit will only be on the circlet. And I just did that for each of these. And then I took that and I multiplied it with this chart, basically. So 3 line, 1 good, for example. What does this mean? So when it rolls a 4th substat, it means the 4th one is also bad, right? At +4, it would still only be 1 good substat. That's why 3 line, 4 good would be, even though that seems impossible, it's because it's assuming that the 4th substat was good. Yeah, and so it only can get up to 8 because it has 4 rolls left, because one of them was used up on that 4th substat roll. And then 4 line, 4 good just has 100% for all of them. So, because in the artifact machine we calculated the probability of the starting substats, like what they can be. Why is this 0%? I forgot. Oh yeah, right, because there's only 3 desirable. Oh yeah, this I don't know why. I like it when 0%. Yay. I just like how it works. The numbers are funny. Oh yeah, when you uncheck like multiple. Negative 10%, and it's still 0% because boop, because it has a 0. So yeah, infallible system, except it is fallible. Sad. So yeah, continuing on with my points. So we have 4 good, 3 good, 2 good, 1 good, 0 good. And my table here has 2 good at plus something. Yep, 2 good at plus 20. 2 or more good at plus 20, 3 or more good at plus 20, and so on. So this would be 1 valuable substat, 2 valuable substats, 3 valuable substats, 4 valuable substats. There's not really a point in calculating 0 valuable substats for obvious reasons. But yeah, so what you can do is, well, I calculated the probability for, say, 5 desired feather and flower, 1 valuable substat, 24.752%, approximately. Not exactly. So that would be, so for a 3-line, in most cases will be, this. Feather and flower, 5 valuable, that's just the label of it, and here. So I put, right, this matches that. Boop, boop, boop. And so we got this cell, 24.752%, corresponds to that. And then times 0.8 is just because there's a 0.8% chance it's 3-line, 0.2% chance it's 4-line, and that is for, blah, blah, blah. That's for artifact domains only. Every other source will be 0.66 and 0.34 respectively. So 6.6 for 3-line, 3.4 for good line. So yeah, it's just multiplying it with the chances to roll. And then gets added up at the bottom. And again, just want to add this as a disclaimer. This does not think crit is any more valuable than attack percent on Hu Tao. Well, yeah. If this is a feather, if this is a flower for Hu Tao, feather flower for Hu Tao, get attack, HP, EM, crit rate, crit damage, that's 5. Right, it still thinks crit is going to be as valuable as attack, even though in practice this isn't true. And it also discards flat attack, even though flat attack does have like a tiny little bit of value. So this is a simplification for like artifact quality, but it isn't for artifact quantity. Basically, it's going to value subsets that do have some semblance of value, like I said in the video. So adding up all these percentages together, right? So 13.54% that it's that 3-line artifact with 1 good subset gets 2 or more valuable rolls. And so just add up all these together, all these cases, right? So 3-line, 2 good, you get the 2 good probability times 0.8. Same thing, but times 0.2 because of 3-line, 4-line stuff, right? And so on. And so adding them all up gives a total percentage yield at plus 20. Would you look at that? 90% of feathers and flowers that have 5 possible valuable substats will have 2 or more valuable rolls at plus 20. Nice. And that's 1 in 1.1. Cool, cool. But then you have to multiply by 20% because only 20% of your artifacts will be a feather or a flower, right? It's just an individual artifact basis. And so out of all of the possible artifacts that you'll ever get, 1 in 5.5 will be like a flower with 2 valuable subsets and a feather with 2 or more valuable subsets, which is a lot, but just remember that it can mean a feather with flat HP, flat defense percent, and attack percent. The attack percent rolls once, and well, that's 1 with 2 valuable substats technically by this sheet, which is why it's so high. Right, and as you go along, the percentage slowly decreases until 0.37% here. And so that's because it needs to be 4 lines for 1, so that's 0.2, and also just having 4 good subsets at a baseline is pretty rare. So that's 1 in 271, which is a lot. And then 1 in 271 odds already, and then out of all your total artifacts, that's like, you have to get, on average, 1,358 artifacts to have a quote-unquote perfect one, and that's not even including, well, does it have double crit? Did all of them roll into double crit? And even, well, did you lose some rolls by getting low rolls? It's such a mess. And they did the same thing here, except instead of 5 valuable, it's 4 valuable, so all that changes is these values here. Woohoo. And so I was lazy, I didn't add this button to the other ones, but basically this just changes the probability from artifact domains to artifact strongbox. So checking this box makes these, oops. So checking this box makes it turn into 0.8. Unchecking it turns it into 0.66. So you'll see this goes down, but in turn, the 4-line one goes up, right? You can see that clearly here. And that was mainly for comparing, like, okay, what's the rate between domains and strongbox? And of course that I talked about that in the video. And so what this mess of numbers down here is, so, right, that's the thing before, just the odds of it having a 4-weight main. That just means attack, defense, HP, ER, EM, all of these with four substat probabilities. That's just what I classify them as for some reason. Then multiplied that with the main stat odds here, got the percentage, then 20% from the artifacts, and then same thing here, except instead of 26.66%, it has 10%. And go all the way down and you see, oh wow, 1 in 58,000 artifacts. Oh boy. How fun. That's not even an artifact domain. Now it's 1 in 100,000 artifacts. Yay. And here, all these are 0% because 4-rate main, but only 3 valuable subsets, so can't have 9. Most you can have is 8, like that. Yeah. So I just did that all down. So non-substat main, damage bonus, healing bonus. For desired, I just checked as many cases as I could that were pretty common. And so, yeah, that's basically what I did. And then just took all those values and ordered them here. So what I found out is that, at least for the earlier stages of artifact forming, like the lower the probability, the less that more substats actually matters, right? You'll see 11.9, 12.38. This is rate. So 1 in 11.9, 1 in 12.8, right? Remember 1 in 5.5 from that first example. And that's the difference of, oh, sorry. It's actually a little bit different. I was looking at this number. Wait, no. I was looking at a grouping of 5 and 4. Oopsie. So it is actually, there's slight differences, but you can see that generally, you can see just how much of a difference that the feather and flower have just because they don't have to worry about their main stat. So you can see, right, there's a difference. Instead of 5.5, it's 1 in 6.2. Instead of 8.2, it's 11.9. But overall, the difference is pretty small, and these are pretty easy to get, relatively speaking, which is why the number for feathers and flowers were quite a lot higher, especially in the baseline investment, right? And that's going down to here. So that's feather and flower for 5, and then feather and flower for 4 is right here. And where I decided to cut it off was right here, or at least in the original baseline investment. So I'll just add a little marker right here. I decided to cut it off here because it was the first instance of a damage bonus goblet. And the reason it's so low is because its main stat is the least probable. So I cut it off at here, honestly, for this. I guess this could have been, hold on. This could have been 2 to 3. Yeah, scaling crit ER, ER attack, right? Yeah, this could have been 2 to 3. What the? Google Sheets is smart. So yeah, anyway, the partitions were somewhat arbitrary, but again, this is also for assuming 4-piece sets, right? You're most likely going to get a more valuable goblet at some point just from farming bosses or doing strongbox, and suddenly, ooh, an offset goblet appeared. This one's pretty good. So yeah, it's a nice upgrade, but honestly, this is pretty important though. The fact that even for 4 valuable substats, you can get a feather or flower with 7 good ones pretty easily, relative to other pieces, although 1 in 120 will still take, right, this is around about, right, 30, this is 34 days worth of artifact farming in domains, so about a month, but it'll be less than that, or less, depending on how you look at it. It could be less, it could be more, right? It's more if you're assuming you're getting 4-piece, less if you're not. Yeah, and so I just went down the list, picked out relevant spots to have a cutoff. Here, right, this is like the middle tier that I kind of chose, so 88655. So looking for a 5 here. Here we go. Damage bonus goblet. So about here. Is that what I chose? No. Of course that's not what I chose. 162. Here's where I chose it. Right. Because there's a big jump between, right, a feather and flower and then the next crit circlet upgrade. And so this choice was a little bit less arbitrary. This one was just because, oh, this is the first instance where damage bonus goblet has been completed. And so after this partition, right, it starts getting, this is 1 in 300, 1 in 500, right, 1 in 1,000, and then damage bonus goblet just sitting here casually with, oh no, this isn't even the order. This is like, oh, this'll take over a year. This will take, what is that, 13 million resin? 1 in 300,000? Sounds like fun. So yeah, here, I was originally going to look more into like the actual amount of damage you gained per substat, but I feel like my concern with the original video was that it would drag on too long with the math and not really focus on like the results and the advice. So unfortunately I did end up cutting out a lot of like details that may or may not have been beneficial. Anyway, all right, the ceiling, remember the 375, this one, yay. So yeah, that's how I came up with the list, and hopefully that explains the math that I did. Just casework because I didn't feel like researching a formula to use. So yeah, hopefully the assumption of average substats ends up accounting for all of the cases that I didn't check. Oh yeah. And so I have a copy of the sheet linked in the original video and also in this one. So feel free to make a copy, play around with the numbers, do what you want. Maybe someone awesome will actually implement this to find like some sort of net damage gain over time. That would be cool, but I don't feel like doing that. I'm gonna focus on other stuff. Yeah. Maybe you enjoyed this mathy math ramble. But probably not, out of like the 3 people watching this. Anyway, bye-bye.